In this presentation, we will be demonstrating the Teamcenter integration to OrCAD for both designs and libraries. In this section, we will be looking at the embedded Teamcenter menu in the schematic tool and doing an initial setup. In OrCAD Capture, I have a schematic design open. The schematic design includes some project parameters such as description, power, and rating to describe the design. So we can see our embedded Teamcenter integration menu with functions to allow us to search for and open designs from Teamcenter to OrCAD, to save those designs, to save them as to new part numbers in Teamcenter, to revise them, to increase the revision level, check them in, check them out, to initiate workflows on designs and parts, and to get design information from Teamcenter, as well as a look at our Teamcenter workflow inbox. This being a new design, we'll use a save as command to pull new part numbers in Teamcenter for the design. Save as dialog shows us the structure that will be created in Teamcenter. The top level is the PCA or printed circuit assembly. The configuration we're using automatically pulls part numbers and revisions for all new objects to be created in Teamcenter. You could also use assign ID to assign the part numbers or enter a value manually. The name of any object can be easily changed by clicking into the field and entering a new name. The first object under the printed circuit assembly is the bill of material. During the save process, we will create a parts list from the schematic design and use that to build a bill of material within Teamcenter. We also create a visualization file of the schematic during the save process to use in Teamcenter Viz. We create a separate schematic part number, so the schematic itself has a separate part number, here again automatically assigned, and we can change the name of it. Schematic part number contains the schematic design data set, the object containing all of the OrCAD design data necessary for creating the schematic. We also pull a part number for the PWB printed wire board, otherwise known as a green board or a bare board. This part number is to represent the bare board within the bill of material. At this point, with a default installation, we could choose Finish and save the design. Using derived data configuration allows us to do two things. If a project schematic and board part number are not sufficient for designs, we can have derived data add additional part numbers to a design. In this example, we're adding drawing and manufacturing part numbers to the design. This can be configured to add as many or as few additional part numbers to a design as required. In addition, derived data can be configured to add separate objects for commonly output data, such as board drawings, schematic drawing PDFs, Gerbers, ODB++. These will be extracted from the design and saved as separate data objects in Teamcenter. With the full design specified in the Save As dialog, we can now select Finish and the design will be saved to Teamcenter. The save is performed and dialog shows the status of the save process. Now let's look at the embedded Teamcenter menu within the Layout tool. Within the OrCAD PCB Layout tool, you can see the embedded Teamcenter integration menu, giving us the same options that we had from the OrCAD Capture. Since this is a new design on the PCB layout side, we will use Save As. The Save As dialog will look the same as it did from the schematic side, with the exception being that the part numbers are already set from the schematic save. There's a new data object for the PCB design data. So the PCB design data goes underneath the PCA. The schematic design data went under the schematic part number. So we'll go ahead and finish, and this save will complete. In this section, we will review the project we just saved in Teamcenter. In Teamcenter, we'll do a quick search for the design we just saved. Finds it, we'll open it up. On the right-hand side, we can see the overview of the project. And on the left side, we see the bill of material. We open the bill of material by itself. You can see the whole thing. See the board, which is the reason we pull the board part number, along with all the rest of the part numbers included in this bill of material, along with the reference designators. And we're packing the reference designators as I'm showing multiple instances of a component in a single line. If we go to the attachments to the design, we'll see at the PCA level the attachments in the board design data set, the board visualization file, and one of the derived data sets that I saved, the layout drawing. To see the rest of the structure, we can use the relations browser. And here we can see the project or the PCA at the top level, the schematic part number related to it, the PCB visualization file and layout drawing, as well as the PCB design data set, the board part number, and our two derived part numbers are drawing and manufacturing. Underneath the schematic is the schematic design object and the schematic visualization file. So the schematic data is under the schematic part number, and the board data is under the PCA part number. Under my manufacturing item, you can see some of my derived data like the Gerbers and ODB++. I've got a board drawing under the board, and all of this, of course, is configurable to what data you want to save, as well as where in the design you want to save it. We can open up one of the PDFs and view it really quickly. And if we open up the schematic design, we can see the schematic attachments, which is the schematic design data and the schematic visualization, as well as we can see the properties that we mapped over. So the description, power, and rating that were project attributes are mapped to Teamcenter properties. In this section, we will look at the visualization capabilities. So in Teamcenter, we'll select our schematic visualization and open it in visualization. We can see the schematic. We can go through the various pages of the schematic. We need to find certain components in the design. We can go to our components list and search for the component by reference designator or part name. So if we select R2, you can see R2, so it'll go to the area and the page where that component is. We can do that with any component and find it. We can also do this with nets. So if we select a net, we'll go to that section of the design. If we select our PCB visualization and open it in visualization, we can see the PCB, both sides of it, as well as any layers we wish to turn on for visualization. And same as the schematic, we can find components in the listing. We click on a component, it will be centered and highlighted, as well as nets. And since we have both the schematic and the PCB, we can have them both open and cross-probe between them. So whatever we select in one design will be found in both designs. You can also mark up the design. Here I'm creating a simple interrogation of the distance between two components. And I can measure a component to board edge also. And we can measure the routed lengths of nets. We also have markup tools such as text, leader lines, boxes, circles. So here we're going to enter some text, as well as the leader lines so that we communicate our design review information. This information is then saved to the Teamcenter design. In this section, we're going to be looking at saving a variant design. In OrCAD Capture, I have a schematic design open. If I go to the Parts Manager, I can see that I have two variants defined in this schematic, variant 1 and variant 2. If I look at the properties of the variants, you can see in variant 1 I have J2 not populated, and in variant 2 I have J3 not populated. So when I go to my Teamcenter integration menu, do a Save As for new design, we'll see the Save As dialog with the printed circuit assembly with its part number, with the bill of material at the PCA level. The bill of material at the PCA level is the master bill of material, or the BOM without any variant conditions applied. We also have the schematic visualization file and the schematic part number. Schematic part number will contain the data object for the schematic design. We also have the board part number, so we can represent the board in the bill of materials, as well as our derived part numbers. We also have a separate part number for each defined variant. So I have two defined variants in this design, variant 1 and variant 2. They both have part numbers defined for them. Contained in the variant parts is a bill of material. The bill of material in the variant is what's populated in that variant. So each variant has its own bill of material with the parts that are populated in that variant. Once we have the design structure set up the way we want, we can hit the finish and save the design to Teamcenter. So let's review the variant project in Teamcenter. So in Teamcenter, we'll use a quick search to find the design we just saved. So we can see the variant project. We open it. And again, on the right side, we see the overview. On the left, we see the master bill of materials. So the bill of material at the PCA level, which is the bill of material with no variant conditions applied. So you can see that it has J2 and J3 contained in it. And if we go to the Relations browser to look at the full structure of the project, we'll see the printed circuit assembly with the schematic part number underneath it containing the schematic design. We can see the board part number, and our derived part number is the manufacturing and drawing. We also see the two part numbers for our variants, so variant 1 and variant 2. We also have some derived data saved under our variants, in this case our drawings of the layouts. We select one of the variants and open it in its own window. We can see the bill of material of that variant. So the bill of material of variant 1, we can see does not have J2 listed in its BOM. This is the BOM of variant 1. And similarly, if we look at variant 2 and open it up, we'll see the variant 2 bill of material, and it does not have a J3 populated. So the variants have bill of materials in them with what is populated in that variant. Let's look at opening designs from Teamcenter into OrCAD. In OrCAD Capture, we'll use the embedded Teamcenter integration menu to search for and open a design. So we can do a quick search for a project that I want to open, find the project, and I can open it further to see its bill of material, as well as its overview and any attachments. Once I find the project that I want, I have the choice of either opening the design for modification, which means check it out for changes, or open it for reference, which means just open it for review. I can also open related designs, so I can open the schematic and PCB in one command. So I'll go ahead and open it for modification, and it's checked out to me. The design's opened in OrCAD. And I can see the project parameters that I had defined, so the description, power, and rating, as well as project ID, revision, and title. So I'm communicating attribute data bidirectionally between Teamcenter and OrCAD. So I can work on this project, hitting save as much as I want to. When I'm ready to save it back to Teamcenter, I can use the integration menu to either save it, which updates the data in Teamcenter, or I can check it in, which saves it to Teamcenter and checks it in as complete. I check it in, I can see the save dialog with the part numbers defined from when we open the design, and I can finish and check the design back to Teamcenter. In this section, we will look at initiating a Teamcenter design workflow from OrCAD. So within OrCAD Capture, we can go to the Teamcenter integration menu, and go to Workflow, and initiate a design workflow. We're going to send a design to a design approval workflow so we can enter some information. And it is assumed that you want the currently open design to be the target of the workflow, so we put that as the default target, but you can search for any other design in Teamcenter that you wish to be the target of a workflow. So we'll go ahead and finish and submit this design to a design approval workflow. If we want to see the progress of a workflow, we can go to our inbox and check on the design approval workflow. See, it's on our engineer's desk awaiting their review. So very easily, any workflow can be initiated from the ECAD design tool. So we're going to look at library integration. We're going to do a part search and initiate a part request workflow. So in OrCAD Capture, we're going to place a database component. So we'll go through our classification structure, find our capacitors class, see all our capacitors in our library. So we'll do a search to find the capacitor that we want to use. So we'll query our capacitor table for a capacitance of 10 picofarads. So we'll just start with a 10, show all the components having a 10 in the value property. So we'll go ahead and narrow that down to 10 picofarads, and notice we have no capacitors in our library with that value. So we need to request a new component. So we'll use our Teamcenter integration and initiate a part request workflow. So we have a new part request workflow. We'll enter information to be communicated about this request. We can select existing components to use as reference or as a component change request, and we can attach documents such as a data sheet to the part request. Request is submitted. If we want to check on the progress, we can go to our inbox and see that the request is at our librarian review stage. In this section, we're going to review the OrCAD library and the setup of the EDA Gateway library integration. So in OrCAD, if we go to our CIS configuration, we can see that we're using a library DBC file as this library, and that DBC file is pointing to an Access database. We open up the Access database, we can see the tables, and here's my passives table with all the components as well as all the fields defining these components. EDA Gateway for Library is our tool for communicating information between a library management system and Teamcenter. You can see the components in the library. And if I look at the configuration, I have the library data on the right-hand side and Teamcenter properties on the left-hand side. And I use this to map library component properties to Teamcenter properties. So part number is going to item ID, part name is going to the name, and so on. So the properties are mapped from the OrCAD CIS database to Teamcenter properties. Once configured, we can now tell Gateway to export the library to Teamcenter. This is done. Gateway takes all the information in the component library and uses it to create components in Teamcenter along with all the mapped information. This way we have a representation of the library within Teamcenter. So if we go to Teamcenter and do a search, we can see the classification structure. Here I'm using the OrCAD class. You can see the various classes, resistors, capacitors, ICs, transistors. We look at our capacitor class. We can look at the properties that were mapped, such as tolerance, voltage, value, power, and current. And we can see the components that were created from that export library to Teamcenter. Each of the components has its part number and its classification information and the map properties. This is how we get library component information from the OrCAD CIS database to Teamcenter. In this section, we're going to create a new component in Teamcenter and sync it to the OrCAD CIS library. So in Teamcenter, our librarian sees a new workflow task. It's to create a new capacitor. So the first step is to review the library request to make sure all the information is attached and see if there's already an existing component in the library that will meet the requirements. So the librarian uses a save search for electronic components, looks in the OrCAD capacitor class, goes down to the values, and looks for 10 picofarad. So we notice we don't have any 10 picofarad capacitors. If we did have some, we could use this and select multiple components and review them and compare and contrast their information between them. But we don't have any 10 picofarad capacitors, so the librarian will approve this task, saying that we have no existing components. At this point, the next task is to actually create the part. So we need to create a new part, classify it, assign the properties, and attach it to the workflow. So we'll use a tile to create a new component. So the librarian will create the new component with the correct name and information. So the component is created in Teamcenter. And now we'll classify it, putting it into the correct class and entering the required information. So it's going to go into our OrCAD capacitor class. We'll enter the necessary information and classify the component. So now that the component has been created and classified, we can review the information to ensure it's correct. Then we can copy the part and go back to our creation task and attach it to the workflow and complete the task. So once complete, we can review the component, see that it has an approved release status with the attached data sheet, and we can use EDA Gateway for Library to synchronize the component out to the CIS database. So any component changes or new components are synchronized to OrCAD CIS. You can see the CIS database has the new component in it with the fields of information populated from Teamcenter by the sync process. In this section, we will look for the new component within OrCAD. So within OrCAD, we will place a database component and go through our classification tree to our fixed capacitors. And we'll go ahead and perform a query on our capacitor table. to look for a capacitance of 10 picofarad. So we find the new component that was created in Teamcenter and synchronized to the OrCAD CIS database.